Hey everyone, this video is for the Wenjuan University Computer Science Students Project at CPS 4222 Principles of Networking. Our professor is Sujatha. Here we'll have 4 students groups project. In this video, they will introduce what they did in their project and how it works. So let's see the first one. The group members are 叶方舟、楼旭东、谢航. Their group topic is Cisco Packet Tracer. Let's see what they did in their project.
The first thing we are going to do is to learn the basic parts of the packet tracer. The first part is router, and second part is switcher, and third part is PC. So let's go to router first. The router has 2 IP, which is 1.1 and 2.1. So the 1.1 is for the left part and 2.1 is for the left part. So let's talk about the switcher. For the switcher is for connecting all the devices, but the switcher didn't need any actual settings. Let's go to the PC0. PC0 has IP address of 1.2 and has a gateway of 1.1, which is the router 0. And PC1 has the IP address of 1.3 and gateway of the router 02. And PC2 has IP of 1.4, and PC3 has IP of 2.2 and has the gateway of 2.1, which is also the router 0. PC4 has IP of 2.3, and PC5 has IP of 2.4. Then we are going to check whether the network is fine, so we are going to run the ping command on PC0. So let's run the command. So now you can see a ICMP packet from PC0 and goes to. So you can see the ICMP packet is from PC0 to PC5 and go back to PC0, which means our network is fine, and we're going to use these knowledges to the later parts. Now we are going to simulate how our IP works. The first step is going to set up the IP environment. PC0 has the IP of 1.1, and PC1 has IP of 5.2. The router 1 has 3 IP for 2.1 and 3.1 and 1.2. You may ask why this router has 3 IPs. The reason is that we added module to it. We add the 1NET module to the router, so router 1 can have 3 IP, and router 2 also has 3 IPs. The first one is 4.2, second one is 3.2, and last one is 5.1. So router 0 has 2 IP, 2.2 and 4.1. Obviously, there are 2 ways from PC0 to PC1. One is from the PC0 to router 1 to router 2, then to PC1. And the other one is from PC0 to router 1, router 0, router 2, and PC1. So how does the system know the shortest part is this way? So the answer is the RIP table. So we have to set up the RIP table to tell the system which is the shortest path. So let's check the RIP table. So router 1 has a RIP table of the network addresses for 1.0, 2.0, 3.0, and router 0 has IP tables of 2.0 and 4.0, and router 2 has IP tables of 3.0, 4.0, and 5.0. Then the system knows from PC0 to router 1 to router 2 to PC1 is the shortest path. Then let's check. Let's run the ping command. It's a ping from the PC0 to PC1. So let's check the package. Package from PC0 to router 1 and to router 2 and to PC1. So that's it. Because we have our IP, then the system knows the shortest path. So that's it. Now we are going to trying to capture the TCP package and analyze it. The first step is set up the environment. As you can see, the PC has the IP of 1.2 and the server has the IP of 1.1. So we set up the IP environment here. Then next step we are going to do is to set up the services for the web server. The first server we are trying to use is DNS. So we're going to have our website name here and have the server's IP here. So that's it. We have the DNS server, and we also have the HTTP service here. So I wrote this website, tst.html. This website only has a string of hello world. Let's just fit this website from the PC. So we're going to use the web browser here. Just enter the website name and click go. Now, as you can see, we have the DNS packet and we're trying to move on. So yeah, so we see that the HTTP package finished transmission, and we can see the content of this website. Now let's go into analyze the TCP handshaking process. First, click at the first TCP packet. So as you can see, first this packet is from the PC to the server, and we should click the layer 4, and we can see it's a TCP SYN header, so which means it's the first TCP packet of the handshaking. We can also check this one, so check the detail. As you can see, it has the sequence number 0 and acknowledge number 0. So let's check the second TCP packet. Let's do the same thing. Click on layer 4. It's the TCP SYN ACK header. So obviously it's the second packet of TCP handshaking. We can also check the before we checking the details, you can see it's the packet from the server to the PC, and then we are going to check the details. The second TCP packet has acknowledged number 1, since the previous packet has sequence number 0, so it makes sense. Finally, we are going to check the last one. So it's from the PC to the server. from 1.2 to 1.1 and click the layer 4 TCP header. So, oh yeah, it's TCP acknowledges for packet and check the detail. It has a sequence number. One for this packet is trying to get the first part of the website content, and the acknowledged number is one. Since the last package has a sequence number 0 too, but in real situation it can be a lot more complex, but they both work based on this principle. So that's it. Thank you.
The next one introduce VLAN project by Li Mu, Meng Xiujie, and Bao Youtian. Let's see what is their project.
Many protocols were using broadcast when using TCP/IP protocol stack, like ARP, RIP, DHCP, and the following three. But huge broadcast domain will also have many disadvantages, as I like showing in the picture. When we initiate one host A and want to find one IP address in another host B, this end device will send ARP request to all the end devices in this huge broadcast queue to request IP address. It will cost a lot of bandwidth and create a broadcast bomb. And also, it's hard for maintenance and will cause a lot of security problems. Therefore, it is very important to separate broadcast domain, and there are two methods to achieve this. The one is using routers to separate, but it is very expensive and needs some devices. The other one is using VLAN to configuration. It is very cheap and do not need other device code. Then I will introduce the definition and benefits of VLAN. In a VLAN, the computers, servers, and other network devices will logically connected regardless of their physical location. The benefit is the VLAN will improve the security of network, and it will help the traffic management, and it will also make a network simpler.
Okay, so this is the overview of our project. If we do not set a VLAN and we create a complex UDP here, and then if we can start, it will broadcast to all the end devices and received by the destination host. Yes, as you can see. And if we create a VLAN, and we can see this is CPS, this is end devices in computer science department, and this is 1, this is 2, and 3, 4, 5, and we send the CPS department computer as a virtual local area network. So if we can start, and we can see this UDP is only sent to the CPS department without sending to the finance department. And this is the overview of our project. And we will receive here and go back to here, and at the end we will receive the CPS destination.
Now I will talk about what we learned in this project. In this project, we learned that the virtual LAN or VLAN in any broadcast domain that is partitioned and isolated in a computer network at the data link layer. And we can set up the VLAN depends on the port, MAC address, which is used in this project, the subnet, and the user. Once we set up the VLAN in the network, the port that connects with switches should be switched to the trunk link rather than the accessible. The trunk link can forward the multiple ports in different VLANs. The data frame in the trunk link contains the VLAN ID in Type Control Information, the TCI, to identify the data should be forwarded to which VLAN. This feature can reduce the processor and bandwidth usage. Thank you for watching this overview.
The last two groups both pay their attention on RP protocol, but they are very different. In Jeremy's project, he verified RP protocol, showing us what is RP protocol very clearly. And at the last one, Li Jinsong's project, he compared RP version 1 and version 2. So let's see more details on their project.
So, hello. Basically, I made a simple mode to verify RIP protocol. As you can see here, this is the mode of the router and the PC. This 2 is the PC, and this 3 is the router. The router will send a message to router or to PC, and the PC will receive it. So to verify the RIP protocol, the main purpose of this project is to verify 3 functions of RIP. The first one is that it will discover its own delivery route, which you can see from here. When I click it, I will put the network address here. I will put network address here, which is 20.0.0.0, which is this one, and then edit it, and successfully edit it. And then I will put 10.1.0.0.1 and put it inside it, and it is this router. This router now has the message now, and I will put the same thing on this 3, which because I have already done it before, so I have to delete it first. The first one is 0.0.0. Edit it, and it's it's 30.0.0.0, and another is 192.169.0.0. Edit it, and then it's this one. This one is also the same. You put 10.0.0.0 and remove it first. Edit 10.0.0.0, and then it's 30, and another one is the 192.169.1.0, and edit it. So you can see all 3 routers has the message, and when I can click the capture forward, it will show that it will find its own way on its own message sending way. And because this host is not open, so it cannot receive any message. And after I do several times, the message has already been sent it. Yeah, from here, then the message is down. So from here, message is down. You can see. So I can click this bar to show what's the router of this way, the routing table. Here I will see different network here. The C1, the type C, is the router that is strictly directly connected to the router 2, and others like R, this R1. R1 is the way that it find by itself. Here, and here. This is the R1. So let's choose that it will automatically find its own way. And another function we can see is the IP protocol, which means it will find the shortest route, but not the route with the biggest bandwidth. Here you can see the difference because I use DTE, so it will show that the bandwidth is much bigger. So if it is not IP protocol, it will go this way. If we send a message from here, it will go this way. But if it is IP protocol, then I put a message here. You can see from it that the message will send from here to router 1 and strictly to router 1, and it will go to PC. So that shows that IP protocol in this way. So that's all about my project. Thank you.
Hi everyone, our project on networking is to compare the IIP version 1 and version 2. The IIP protocol, or called Routing Information Protocol, is one of the oldest distance vector routing protocols. The simulation tool we choose to use is the Cisco Package Tracer. It can add components by dragging and is easy to learn. It's also friendly to beginners. For our project, we prepared 4 simulations which are linear version 1 and 2 and map ones. The linear one is as simple as 15 routers connected one after another. The map one can be shown as a picture. The number on the line represents only the index of the network but not the weight. I'll take one router in map version 2 as an example. I set a network to connect the switch and the personal computer, and several networks to connect other routers. At the router setting of RIP, it records the network this router directly connected. When the simulation starts, the router will update the routing table every 30 seconds, by which they can connect each other through other routers. After finish updating the routing table, one PC can send the package to other PCs. Our project wants to find the difference between RIP version 1 and version 2 by finding the delay time of the package sending. To test it, we will send ping between PCs by sending 32 bits package and record the minimum ping, maximum ping, and the average ping. Like this. We collect the data for several conditions, and as shown, here is our result. As shown in the result, we do 5 times for each test, and each test contains 4 package sending. And use that 20 times of data sending, we come up with the final result. The upper line shows the delay time of data sending between 2 directly connected routers, and the lower ones represent the delay between 2 routers having 3 routers between them. And for these 3 lines is linear version 1, and this for linear version 2, map version 1, and map version 2. As a conclusion, we find out that there is no significant difference between version 1 and version 2 in delay of data sending. With the further research, we find out that the difference between 2 versions is version 1 can only broadcast, but version 2 can groupcast. This is our project. Thank you for listening.
After the whole class finished their project, our Professor Sujatha held a demo present class. Everyone will present their project before the sophomore students and explain the project in understanding words to show what they learned from this CPS 4222 principles of networking. And we have some videos on that demo present class.
But for some reason, the server cannot define. The server cannot ensure which message you will be sent. For original one, you should be sent to USA player because you guys use the same IP address. The server is confusing, so it's a mistakenly send a message. So you are that. Okay. So how can we avoid this? We should use net. The net is actually like a mini program installed in the net router. We call it the net router. Actually, the net router will be installed for both client part and the server part. So in every net router, when you send the message to the server, you should first pass through the network, right? So the router will get the message that your IP address will want to send a message to the server. So the network will automatically transfer, or you can say modify, another IP address that faces the worldwide, for example, this one to the server. So the server will get this IP address instead of this. The same for the USA. Yeah. But the IP address is different. So the server can be sure about which side the message will be sent. This is the fundamental control for that technology.
Send and receiver is synchronized. A larger string of data is sent one character after another. This kind of protocol can increase the efficiency a lot. The second is mechanical QQ. Basically, QQ uses Unity to transport the data. It has a low consumption of system. Resources has a fast speed of delivering messages. But although such it can also omit the handshaking compared to TCP. And because of the omission, we also expose the source package any unreliability of the underlying network. There's no guarantee that the destination can be And last is the mechanics to WhatsApp. WhatsApp adopts SMPP, which means extensible messaging and resource protocol. It is a widely used protocol for message-oriented middleware. This protocol allows Java messages and data to communicate from one client to another through servers. Since XMPP is based on the XML, it's more extensible and flexible compared to other protocols. And to evaluate the performance of each protocol, we use NS2 simulator as well as several possible simulations. And this diagram shows our working flows. First, we take the QQ and WeChat and WhatsApp for these three applications. Those protocols are UDP as well as SMPP. And then we simulate them on the NS2 simulator and get the possible results. So next, let's welcome Rupert to introduce evaluation applications.
Okay, I will talk about the evaluation metrics. And basically, our research is find out to compare the three protocols. What kind of things that we compare? So we propose several quantitative metrics to compare the three protocols, which are frequent generated packet loss. I will talk about it. The first one is throughput. Throughput basically talks about whether the speed.
Network address how to translate. In our presentation, we will just introduce this one. Just like friends.
Only static you explain to them, and then your project. How the address is translated.
Just like friend. Here is your computer and with this IP address, and this is the NAT router. If you want to access this server in the Ethernet or public network, you have to send your message through this router. But this is what we call the inner net. And this is when you pass this information, or when you want to access this server, because in your place, you cannot directly access this IP address just like this one, and this is the port number, port. So how can we access this server without an AP? So this is a big problem. So the engineer invent this technology. It's just like Frank told you before. In NAT router, we have a translation table.
Thanks for your watching. That's all. If you have any question, you can contact Sujatha and Little One.